Hopefully not. Okay, so the first set of identities we're going to look at are called our sum and difference identities. Yes, this is the first set. So the first sum or difference identity is going to be sine of angle A plus B, written as sine parentheses A plus B. A here is just going to represent the first angle, and B is going to represent the second angle. This is equal to sine of angle A times cosine of angle B plus cosine of angle A times sine of angle B. I know, it's crazy. The next one we have is sine of A minus B. Order here is very important, so make sure we maintain it. This is equal to sine of angle A times cosine of angle B minus cosine of angle A times sine of angle B. Yes, it does. No, not once you put angles into it. You're so funny. Next, we have cosine of A plus B. And this is equal to cosine of angle A times cosine of angle B minus sine of angle A times sine of angle B. And then we have cosine of A minus B, which is very similar, but with addition in between. Oh, this is a heck of a lesson to miss. I've seen it today.
Oh, frick. How did you write all of that?
I'm magic.
I'm still in cosine A plus B.
We also have a set of tangent sum and difference identities. I will use a different color for that one. So the first one is tangent of A plus B. And this is equal to tangent of A plus tangent of B divided by 1 minus tangent A times tangent B. Yes, Jonah.
So for the cosine angle A plus B, why would it be subtraction?
It's just how the cosine and sine work out. It doesn't make sense. I wish it did. It'd make it easier to remember, but this is the way that it proves out.
Ew. But I gotta say.
We have one more. We have the difference for tangent. So tangent of A minus B is almost identical to the tangent of A plus B, but the signs are different. So this one is equal to tangent A minus tangent of B divided by 1 plus tangent of A times tangent of B. Oh, this is just the first set.
My brain's already fried.
There are 5 more sets.
Oh
my God.
No, of special angle identities.
So this is just the one identity.
This is just the one identity for 3 trig functions.
We're gonna have a test on this? We're gonna remember all 27?
Well, you're there's more than 27. You're definitely gonna want to write these on your cheat sheet.
These aren't even fit on my, we better be getting a big cheat sheet.
So let's go ahead and do an example that uses one of these identities so we can see how it works. So the example I would like to use is cosine of 5 pi over 3 minus x. Which one do you need, Stephen?
That one goes.
Okay.
Come on, man.
So obviously we have calculators, which make these kind of useless. However, your next test will have a no calculator portion to it. in which you will not get a calculator, so you'll have to use
No.
these to simplify. So what we're gonna do is we're gonna practice not using the calculator and instead using the values from our unit circle. So as I'm looking at this, the example I have is cosine of 5 pi over 3 minus x. So that means I'm gonna go to my list of identities and I'm gonna find the one that is cosine of angle A minus angle B. So that should have been the fourth one that we wrote. Y'all see how I identified that one as the one we're using? Because it's cosine, it's subtraction. Super easy.
Yeah.
So 5 pi over 3 is my angle A. X is my angle B. So I'm going to write out that identity plugging in those respective angles for A and B. So this is equal to cosine of angle A, which is 5 pi over 3, times cosine of angle B, which is x, plus sine of angle A, which is 5 pi over 3, times sine of angle B, which is x. So I went to my list of sum and difference because it's subtraction, which means I know it's difference. I went to the cosine one that is difference, and I wrote the identity, but instead of putting in A and B, I put in the two angles that I had been given.
I don't even know what's going
I literally just said it again, Devin.
on. I know.
So I saw this was cosine and it was subtraction, so I went to that list we wrote down, and I found cosine and subtraction,
And then you just,
and then I wrote that out, but plugged in the angles for A and B.
oh,
That's all I did. Are we all kind of ish okay with that?
Yeah.
So X is B in this case.
X here is B, yes. So looking at this, there's not a whole lot else I can do except replace some of these trig functions at certain angles with their respective values. So the first one I'm going to replace is cosine of 5 pi over 3. To find this, I'm going to go to the back of my unit circle where I have a huge chart. I'm going to go down until I find the angle that is 5 pi over 3, which is 300, as Zach pointed out. And I'm going to follow it over until I get to my cosine column. And that number is what I'm going to replace that with. 1/2. I can't replace cosine of x because, well, I don't know what x is. So that one stays. So now my first term becomes 1/2 times cosine of x. Are we all okay with that? No, because the 1/2 became its own thing. So now I'm going to do the same thing, but this time I'm going to do it with sine of 5 pi over 3. So again, we're going to go to that chart. We're going to find the angle that is 5 pi over 3.
so that whole goes.
Negative square root
Yes.
of 3 over 2.
I follow it over until I get to the sine column, and what is it going to be, Zach?
Negative square root of 3 over 2.
And then times the sine of x that I cannot replace. Do we all see what happened there?
Yeah.
So technically, this is starting to look pretty simplified, but I'd like to go a step further. Is there anything that both of these have in common other than the x? Because I can't pull that
Two
out.
on the bottom.
I did 9.
The 2 on the bottom, which is the same as having 1/2 being multiplied into both of these. So I'm going to pull that 1/2 out. And then what's left is my simplified answer. That is the best that we can do here.
So we don't have to like solve it.
No, we can't. We don't know what x is.
That's the answer.
But there will be times on your homework where you absolutely can, because we know what the second angle is.
So if I just strip down, how much of my grade?
Also, the perfect one.
Okay, so what if we did know X and then we had the square root of 3?
So we would take whatever x was, and I'd multiply it by the square root of 3, and I'd get an answer. So you would have a 1 number or 2 number answer if we knew what x was.
So you just type in like square root 3 sine, whatever.
If you were using a calculator, if not, you would leave it at square root of 3 times whatever sine that angle was. We will do examples that have 2 angles in them. I just wanted to use this one so we could kind of see how the process worked. So let's go ahead and look at our second set of special angle identities, and those are called our double angle identities. So this means I'm taking some angle x and I'm multiplying it by 2. So the first identity we have is sine of 2 times the angle x. And this is equal to 2 times sine of angle x times cosine of angle x. Chandler, we get the door.
Who is it?
It's Jerry. The next one we have is cosine of 2x. There are actually 3 identities for cosine of 2 times an angle. We're going to list all 3 of them. So the first one is cosine squared of x minus sine squared of x.
You missed a bunch, by the way.
The second one is 1 minus 2 times sine squared of x. And the third one is 2 cosine squared of x minus 1.
Is there assignment tonight?
Yes.
Wait, for the second one, that's 1 minus 2?
That's 1 minus 2,
Okay.
yeah. And then we also have a tangent double angle identity. And just like with everything else, tangent, it's much more complicated.
You will never use this one.
Never ever.
Oh, nice.
SAT, yes, maybe.
Maybe on this thing. Why is most education nowadays just learning for the SAT?
Because that is what they define as case studies. They give us a list of things and you have to learn them.
So they identify education about exactly what you don't need.
No, back in my day, we did.
Let's stop arguing and let's just go ahead and write it, please. I don't decide what you get to learn. Unfortunately, the state does. Let's just make the best of it. And actually, all of this learning does help develop your cognitive skills.
What does that mean?
Clearly, Jerry needs more than most. I'm just kidding, honey. It helps to develop your critical thinking skills. So the ability to problem solve, the ability to think through a solution, given a problem.
I think I'm critical thinking right now. I'm gonna drop out.
So what did I miss? Or did you-
Another set of these, that's all. So you'll just have to go back and look.
It's scary.
So let's go ahead and do an example that is involving our double angle identities.
That's it for the double angle?
That's it for the double angle.
Oh, thank the Lord.
Don't thank them yet.
Oh. Hey, buddy. Wait, no, we still have one more.
I don't think I brought the pencil in.
This one's gonna be a 2 and 1.
What does that mean?
We're using 2 identities. Not cool. So the first thing I'm gonna do, because I don't have a triple angle identity, I have a double angle, but that's it. So what I need to do is I need to make this into something that has 2x in it. What can I separate 3x into that has a 2x in it?
Wait, 3x separate
1 minus
2x.
2.
Obviously.
The third cosine.
How about cosine of x plus 2x? Because right, x plus 2x equals 3x, right?
Just divide an X out.
We're just separating, it's no different than having 5 and separating it into 2 plus 3. I know they're equal, but I separated it out to make it fit what I needed it to fit. So this is equivalent to cosine of 1x plus 2x, right? Because 2 plus 1 equals 3. So I separated it out because I didn't have an identity for 3 times an angle, but I do have an identity for the sum of 2 angles inside a cosine function and for a double angle identity. So we're doing 2 and 1 here.
So if that was 4, you could do it cosine 2x plus 2x.
Somebody like Kennedy.
Okay, Kennedy.
So now what we're going to do is we are going to go ahead and separate this first using the sum identity for cosine. So what is my sum identity for cosine?
That's why I'm late, because he's gonna give me a lecture.
Okay.
Mr. Barnes. And he said, by the way, thanks for the flowers. Take 'em
What
away.
is our sum identity for cosine?
Hold on, I can do this.
Yeah, go back and look, we got it.
Wait, it's all the way at the top.
Yeah,
That'll be the first one.
Times cosine B.
Cosine A plus B equals cosine A times.
hold on, you
cosine
gotta list it slower.
B. Okay,
So,
cosine A plus B
uh-huh,
equals cosine A times cosine B minus sine A times sine B.
so all I did then was I substituted x in where angle A was and 2x where angle B was, because those are my two angles. And then from here, I can continue to simplify. I don't know what cosine of x is or what sine of x is, but I have double angle identities that I can simplify cosine of 2x and sine of 2x with, which are the ones that we just wrote down.
How do we know what formula to use?
What do you mean?
Like how we use the cosine.
Well, because it was addition and it was cosine. There's only one of them that fits both of those. That's how we knew.
So you think the last quiz was bad? Wait until this.
I'll give you actual angles for this one. I promise.
I know. That's what I'm saying.
So let's go ahead and simplify this some more. The first thing I'm going to do is I'm going to replace cosine of 2x with one of these three identities. How do I know which one I need to choose?
Some math that you
It
know.
doesn't matter.
It's a feeling.
For this one, it doesn't matter. We are going to use the same one though, that we ensure that we can work through it algebraically together. So we're going to use this one
Why not tangent? Yeah.
because we don't have a
But
tangent
it's
function.
not tangent to x.
I said which of these three cosine ones
Oh.
because they're all the same
Then you choose
but
sine.
different.
Oh, you just picked a random one.
I picked a random one, and that's one you're also going to use, yes. So I'm going to replace cosine of 2x with 1 minus 2 sine squared x. Minus sine of x times, and then I'm going to replace my sine 2x with 2 sine x cosine x.
Basically replacing all the cosines with like.
I was replacing all my double angles with their respective double angle identity.
Probably just tell this whole.
Your hair looks cute.
Thank you.
Yours too, Jenna. Does everybody see what I replaced? So I replaced the cosine of 2x, and I replaced the sine of 2x because I had identities for those. We just wrote them down.
Where did you get the two x's from?
Oh my lord. We separated this like an hour ago. So 3x is the same as 1x plus 2x, right? So I made it into an addition problem. This was my A, that was my B. So I did my sum identity and then replaced my doubles with the double angle identities that we just wrote. That was not FOIL method. We have done no multiplication so far. Literally none.
Yeah, stupid dumb.
We're about to though.
So why did you replace those?
Because my goal is to simplify this as far as I can without having any other identities that can be replaced. So when I did this, I knew I had an identity for 2x, for sine and for cosine, because we just wrote them down. So I'm using this to continue to simplify it down into a much easier function to work with, since we technically don't have a calculator for this problem.
It just looked like you just made it bigger, but.
Yeah.
I did, but it's actually going to make it smaller in the long run.
I have a serious question.
Yes.
So when we test over this and we have a cheat sheet, can we just do open books or have to write all it again?
There's a very good chance I'll give you a notes portion, yes.
Okay.
I can't say open book entirely, but I'll definitely give you a chance. So now what we're going to do is what Steven suggested. We're going to multiply this all together and see if we can simplify it out any farther. Technically, there's no foiling happening because I don't have a binomial times a binomial, but distribution, yes. So for this first one, I'm going to take cosine of x, and I'm going to multiply it into both of those terms. And then I'm going to take sine of x and multiply it into that term.
Make it even longer.
Yes, it is.
Oh.
So this becomes cosine of x minus 2 sine squared x
One question.
times cosine of x, and then minus 2 sine squared x cosine of x.
Want it to be -2? The negative sign.
Right, so -1 times 2 makes it -2.
I didn't see the minus.
Yeah.
Oh,
Yes.
no.
So all I did was I distributed cosine times 1 is cosine. The cosine multiplies this into this and just adds on to the end. And this sign combines with the sign that was already there to become sine squared. Why was this helpful for me?
Now you don't.
I don't have parentheses. What else do I currently have though?
Multiply them and make them 1.
How about I have two terms that I can add together? Because I have 2 sine squared x cosine x and 2 sine squared x cosine x. So now I have the same term twice. So I can add the coefficients together and it becomes -4. So this becomes cosine of x -4 times sine squared x cosine of x.
Is that it?
We're almost done.
How many questions are
Isn't
gonna be on
that like -2 sine squared x times cosine x for the first one? Or is that just a random dot?
That's times.
Yeah, that's times with multiplication.
So
It doesn't really matter if you have.
It was the same thing. I like to put the dot, just don't think they're all one function. But I didn't put the dot here, but it's the same thing. It's still multiplication.
The one that trick you.
The dot's
It
so
did.
small.
it did that.
You know, most teachers are deceitful.
The sequel?
Is that even the right
Thanks.
word to use?
With her
Look it up.
government quick tests.
And it lost.
You
You
did
just
it
call
to
me
yourself,
deceitful?
I said most teachers.
taking honors.
What does that even mean?
So
That just-
would you subtract?
You deceive
That
us?
just kind of broke my heart, man.
I wasn't referring to you. I was talking about.
OMG.
I feel like the answer's gonna be negative.
I'm
Okay.
Where we're
What they all say.
Technically, from here, we could go ahead and pull a cosine x out of both of these, but this is actually a wonderful place for you to stop. Because from here, it'd be really easy to plug an angle in and get an answer. So we have simplified this down far enough for you guys.
That's the answer?
That would be an acceptable answer, yes. That's as far as I'm requiring you to go. I did go farther in the notes if you'd like to go back in, but there was some more substitution that happened. So I figured you guys don't want that.
No.
So what we're gonna do instead is we're gonna move on to the next set of special angles.
Yeah. And then after that one, we got 3 more to do.
That is true.
Ah. Right.
We could take a picture of all of that. I'll write them.
They're on the notes too.
Oh, all I gotta say.
More
Yours is color coded though. The ones online, aren't they black and white?
Well, yeah, because that's all I can put on there.
It's scary. You know what word is black and white?
Racism.
Are you racist?
Yeah. We're black and white jacket.
More equals one.
No, that is not 20.
Oh,
That is 2 theta. It's no different than using 2x. I'm just showing you that there are different things that can be plugged in. So this is a continuation of the double angle identities. We did sine, cosine, and tangent. Now we're going to do cosecant, secant, and cotangent.
Okay, did that take up one whole page?
Don't
So like, am I
Yeah.
going to use the
Yeah,
back side?
you're going back.
Yeah, there you go.
Okay, so this is your cosecant 1. Instead of x now, I'm using theta just to show you that they are interchangeable. So cosine of 2 times angle theta is equal to 1/2 times cosine of theta times secant of theta. Our secant double angle identity then is equal to secant squared theta divided by 2 minus secant squared theta. And then our cotangent double angle identity is equal to 1/2 times cotangent of theta minus tangent of theta.
I bet the homework's gonna be like,
We have homework time.
Yes.
Oh.
that's horrible. How many questions are on?
Not a 10.
Not gonna do it. Should be able to-
I think it's 10 or less, honestly.
Just do it.
5.
Well, if it's this, then it's too much.
Well,
I will be happy if we can get halfway through.
We can have like through after this.
oh.
I bet one of
I'm gonna
these.
flip you off or something.
One of these got like 12 different things, don't they?
Let's go ahead and do an example.
She didn't answer. That's not.
She smiled actually. So that's scary.
We don't need a calculator for this, do we?
No, the whole point is that you don't use a calculator.
Because
for
we don't
this.
get one on the
Our
test.
quiz is no calculator.
A quiz will have a no calculator portion and your test will have a no calculator portion. Specifically for these. And some other things we're gonna learn, but these specifically.
We are the calculator.
Okay, so the example we're using is actually an actual angle example, so you guys can stop complaining. So I would like to use tangent of 2 times the angle pi over 6.
Oh, that's 6.
Yeah, that's a 6.
30.
I thought that was a B.
So am I using this set of double angle identities or the set we already wrote down?
The second one wrote down.
So let's go back up to those and let's figure out what our tangent double angle identity is.
2x or 2, 3.
So the only difference is that wherever the x is, I'm gonna go ahead and plug in the pi over 6. So that means my double angle identity for tangent where theta or x is equal to pi over 6 is 2 tangent of pi over 6 minus tangent squared, over 1 minus tangent squared of pi over 6. Are we all okay with what I did there? I just replaced the x's with pi over 6. I'm gonna do something else that might also help you here. 1 minus tangent squared pi over 6 gets a little bit confusing because we're not really sure where to put the square. So this is equivalent to 2 tangent of pi over 6 over 1 minus tangent of pi over 6 all squared. So those two mean the exact same thing, which helps us when we go to plug it into our calculator, if we were to be doing that, which we're
So is the I over 6 cancel out?
no.
No, you can't just.
No, because it's not being multiplied into the 1. So what we're going to do now is we're going to use our unit circle to actually simplify these values a little bit more. Zach,
30.
you're out of the game. So the first thing Zach did is he went to his chart and did what, Zach?
I looked at the, when I looked for pi over 6.
Okay, and you got pi over 6 is equal to what angle?
30.
Awesome. So everybody go to your 30-degree angle row. And we're going to slide over until we hit what column? Tangent. What is the value of tangent of pi over 6?
1 over the square root of 3.
Perfect. So this is equal to 2 times 1 over the square root of 3 in the numerator. So I just replaced tangent of pi over 6 with that. Over 1 minus 1 over pi over 3 squared. So I literally replaced tangent of pi over 6 with 1 over square root of 3 because that's what it's equal to. Are we all okay with that? Maybe.
I suppose. I mean, yeah, kind of, sort of, not really, but. I'm picking up what you're putting down.
So then from here, we're just going to continue to simplify. So if I take 2 and multiply it into 1 over the square root of 3, it becomes 2 over the square root of 3. In my denominator, I have 1 minus, and then I need to square this fraction. I know when I square the 1, it's going to stay a 1. What happens when I square the square root of 3?
It's just a 3.
It's just a 3, which allows me to continue simplifying this because I know what 1 minus 1/3 is. What is it? 2/3, right? So this is then equal to 2 over the square root of 3 divided by 2/3. I know when I divide a fraction by a fraction, I do what to my denominator fraction? Flip it and multiply it into the numerator. So this becomes 2 over the square root of 3 times 3/2. I recognize that the 2's are going to cancel because they are diagonal to each other, which leaves me with 3 over the square root of 3. We are still not done. You're going to see why in a second. It's going to be really, really cool.
I'm gonna
Wait
go
a minute,
use
wait a
just like
minute.
I did with the one thing, so.
If there's no explosion, I don't want
Is there a finger power?
Shark boy shot, we're gonna have to get rid of the square root.
Yes. Okay. So this is the kicker. We do not like to leave a square root in our denominator, so I need to rationalize it by multiplying that square root into both the top and the bottom. So I'm going to multiply both the top and the bottom of this fraction by the square root of 3. And then I'm going to end up with 3 times the square root of 3 over 3. And then what happens?
I've been running from the.
The 3 is third.
The 3's cancel out. Why is this going to be super cool?
Because it's gonna equal one of these suckers. Man. It's gonna
Square
equal
root of
another
3,
angle.
60 degrees.
Hold on.
Square root of 3.
Because you're gonna.
Stop. What was pi over 6 equal to? What angle?
30.
What's 2 times 30?
There's 60.
60. Go to your 60-degree angle, row.
Stop the cap.
Slide over till you get to tangent. And what's
Stop.
tangent equal to?
Stop the cap.
Root of 3.
That's crazy.
You're lying.
Square root of 3.
Oh, we also have another square root of 3 at 240.
You know.
Well, yeah, but I mean, like, it worked for this double angle. It
So
doesn't
hold
matter.
on.
Got the
So we
golden buzzer.
multiplied by 2.
Well, yes, if you had a calculator, you could do that. But you don't necessarily always have a calculator, so these always work as well. Zach.
So you're telling me, once I find like that I get like, once I find my first degree, I can just multiply it by 2, like in this scenario?
To check it, yes. To solve it, no, I expect you to do all this. But I wouldn't give you one that it required this much work.
I do have a question.
Yes.
Please tell me we're.
Are we gonna be able to check our answers, check our answers with a calculator?
Wait,
Well, here you can check it with the unit circle, but on a test, if you have a calculator, yes, you can check it with a calculator. That's fine too. Jerry.
Oh, you just took 30 times 2 to get to 60.
Yes, to check my answer. I thought it was kind of cool that it worked out perfectly.
That is pretty cool, man.
I think it's pretty cool.
Did anyone hear what I said?
We're gonna do one more.
Like another set or like
One more
another-
set, yes.
Like another page?
How many is there? Do I need to flip my
There are
page?
3. 6, there's 6, just
Oh,
kidding.
yeah, flip my page.
3 more or 6 more?
We are doing 6 more trig functions, but one set of identities.
Oh yeah, color. It's like bright.
I like it. It's white without being white.
It's creamy.
You don't say that.
It's not creamy, that's tan.
It's
tan.
peach.
That is not peach, Miss Ma'am.
It's peach.
Oh, that's
Peacher than a
vibrant.
peach.
Vibrant color. What?
Oh my.
Read it out. Come on, read it out.
Oh.
Yeah. Oh, Lord.
All over 2. Yeah, can you
Wait.
bring back the quadratic equation? I like that
I mean,
better.
I remember they gave us the notes.
I don't.
That was in geometry. That's never gonna happen.
That's never gonna happen here.
So
What?
don't think about
Me
it.
printing out the notes.
Cause
Why did you do it in geometry? You didn't do that for me.
Because there were lots of shapes.
It's just lots of words.
Wait, so are you saying like
Yeah,
that
but
first one you
you
wrote
write
down
it down
sine
yourself, the more
squared x equals
It's a
cosecant squared x, or is that like?
No, so I'm telling you that sine equals this, but cosecant, since it's reciprocal, is this just flipped over. So that's why I wrote them across
So
each
it's
other
like
so you can see
different-
that. Yeah,
So they don't equal each other?
Correct.
Okay.
correct.
What does it say? 1 plus cosine?
Are they all cosine?
Yep.
Why do they all have cosine?
Because that's how it all proofs out. If it makes you feel any better at all, my honors class is gonna have to do the proofs for every single one of these.
We have to do what?
The proofs.
Ooh,
Yeah.
glad I didn't take honors.
This is a good time not to be in that class. Yeah.
Do you remember when Harrison literally switched out of here to go to honors?
Yes.
I thought he
Yeah,
was
just in case anybody wanted to know, he complains every day about it.
Oh, I do not doubt that one, but he complains in class too.
I told him he's
I don't
stupid.
miss it. I was like, you are so dumb. I don't miss.
This is the last one I'm gonna do though for you guys, okay? Today. We're gonna
Okay.
continue this on Monday.
Still
And
right.
we're not gonna do an example of this either.
Still right.
That's perfectly fine. Once you're finished, I'm finished with notes for the day. There is homework and you can absolutely do it on Canvas. And, I don't care.
I would like to get out of here in a little bit.
In like 13 minutes.
You,
And that's why I'm gonna get one
So like
problem.
we pretty much have to do it.
Got enough time to get one problem done, boys and girls.
I'm
Is that high enough for anybody?
scared.
I haven't been on my computer all day, it's about to die. At 2%. Probably.
That JJ Watt is leaving the Texans.
So it's Deshaun Watson.
No, I got bandages.
Oh.